Okay, so this is the last part of our section on rational expressions, and these are complex fractions. Complex fractions mean they have a fraction within a fraction, and I'm going to do a few examples from the book. They're going to be even numbers, so they'll correspond to some of your homework if you look for the odd number right next to it. Let's start with number 60. Here's how we do these. Look at all the terms within the complex fraction and identify the denominators within the complex fractions. Okay? What you want to do is multiply the numerator and denominator of the complex fraction by that LCD, or least common denominator. I can see that it's 4. So I'm going to write like this and multiply the top and bottom of the complex fraction by 4 over 4. That means I'm going to distribute. Watch the way I distribute, because these problems are all about organization. I want to have a little space next to each term so I can put this 4. And I'm even going to use the colors because it makes it make more sense when I do it that way. So if I'm multiplying by 4, I'm going to put a 4 up here. And remember, these go in the numerators. So whatever you're multiplying by, it's going to go in the numerators. And the reason we do this is now we got rid of that fraction right there. On top now, that leaves me with x minus 4. And on the bottom, I have 4x minus 16. Okay, on the bottom, I can factor out a 4. So I'm going to use my colored pen to do that. And now I can see, oh, x minus 4 cancels out. When you have a blank space, it leaves a 1. My final answer is 1/4. What do you think? Do you have any questions on that one? You don't necessarily have to copy it because you'll have this video in just a few minutes. I'm going to continue on. When I look at this complex fraction, okay,
Can
I'm
you
waiting.
explain it one more time?
Which part?
Can you explain the whole thing one more time for me, please?
Okay. So I have 4 terms here, and I identify all denominators. I want to multiply the top and bottom by something that's going to cancel out every denominator. And that's going to be the least common denominator. Lucky for us, there's only one denominator, it's 4. Multiply top and bottom by 4, and then distribute. When you distribute, you're going to write a 4 next to each of those terms. See, the 4 goes to this fraction and the 1, and the 4 goes to the x and the negative 4. Then multiply it out. When I multiply it out, my whole purpose was to get rid of the fractions within the fractions. That leaves me with x. 1 times 4, that equals 4. X times 4 is 4x, and 4 times 4 is 16. Once you're right here, you're going to use methods from yesterday's lecture about how to reduce this, how to simplify this complex fraction. So I'm going to factor the bottom. I'm going to take out a 4, undistribute a 4. That means you're dividing it out. You're going to be left with x minus 4. And that happens to cancel with the x minus 4 on top, leaving us with a 1 and a 4. 1/4.
Okay.
Now, I didn't
So
do this. Wait, one quick second. We should have put in our excluded values. Go back to the beginning for your excluded values. And you can see right here from this fraction, x cannot be 4. Okay, question?
okay, I get that. So why did you use the 4 instead of the x minus 4? Because that's like the common denominator.
Right here?
Yeah, like at the beginning. Yeah.
Okay, because I can see you have to think about relatively what the terms are. So if I have fraction minus 1, then here's the level that I'm looking at. I'm looking at this term, this term, this term, and this term. Those are my 4 terms that I'm looking for at the denominators. I don't want to look at this entire denominator down here. It's not going to help, actually, because we're going to cancel it out and then bring it right back. I don't know how to explain that to you without doing it, but that's just the case. And I think when you see a few more examples, you're going to catch the hang of what I mean by look for the denominator so that you can cancel it out.
Okay.
Maybe we should go to the next one so you'll see what I'm talking about.
All right.
I have x minus 3 over x minus fraction. Do you understand how I'm reading it? X minus 3, x minus fraction. The only fraction I have to worry about is this one here. There's my denominator with my my only denominator, so my least common denominator is x minus 2. Let's multiply top and bottom by x minus 2, and let's distribute. This will go to each term in here, okay? So I've got x minus 3. Notice I'm leaving space because that's where I'm going to put my blue thing I'm distributing, my blue expression. So I distributed an x minus 2 here. I distributed one here, here, and most importantly here, because that's going to cancel out my fraction within a fraction. Now let's start multiplying out and simplifying. Distribute here, giving you x squared minus 2x. Distribute the minus 3, giving you negative 3x plus 6.
Can you scoot it down just a little bit?
Yeah.
Thank you.
How's that? Let me repeat those in. X times times negative 2 gives us x squared minus 2x. Negative 3 times x, negative 3 times negative 2 gives us negative 3x plus 6. Here, I have x squared minus 2x. And be careful here. You have a minus 3 still. Let's continue. And I'm going to have x squared minus 5x plus 6 and x squared minus 2x minus 3. Oh, we're not done. The top factors and the bottom factors. The top, what two numbers multiply to 6 and add to negative 5? It's negative 2 and negative 3. On the bottom, what multiplies to negative 3 and adds to negative 2? It's negative 3 and positive 1. My negative 3's cancel out. We're going to leave our answer as x minus 2 over x plus 1. Any questions? Sharif, what do you think?
Yeah, I'm still like a little confused, like how you do the thing, like which one you choose at the beginning to like distribute and stuff, like the
Okay.
x minus 2.
Okay. So let me do another one with more with numbers, and maybe this will help you understand that concept. Okay. What if I had x over 2 minus 3x over 5?
Can't see it.
Oh, my bad. Right there?
Yeah.
X over 2 minus 3x over 5 over 4x over, I don't know, 7 plus 1. Okay. Now, I can see I have fraction minus fraction all over fraction plus 1. I'm going to circle all of my denominators. And now I want you to find a common denominator. It doesn't even have to be the least common denominator. I just need a denominator that will cancel out a 5, a 2, and a 7. Tell me a number that will cancel all three of those out.
Nothing.
Say it again.
Nothing will cancel all three of them out.
Really? Think about this. 2, 4, 6, 8, 10, 12, 14, 16, those all cancel out of 2. If I put 16 up here, it cancels out the 2 because it'll become 8x. I need one number that will cancel out all 3. Now, since they're prime, it's kind of easy. You just multiply them. So 2 times 5 times 7 will give us 70. And 70, in fact, will cancel out everything. Let me give every term a 70. See, I'm already jumping to my distributive property here. I distributed it to every term in this complex fraction. The 70 cancels with the 2 to give me 35. The 70 cancels with the 5 to give me 14. The 70 cancels with the 7 to give me 10. Let me rewrite my fraction now. Right here, I've got 35x. Right here, I've got 14 times 3. 14 times 3 is 30, 42. On the bottom, I have 10 times 4x, which is 40x. I've got plus 70. These can be combined. They're like terms. We'll get negative 7x over 40x plus 70. And we're done. Okay, so that's how you choose the least common denominator. You need something that's going to let us cross out every denominator within our complex fraction. What do you think?
Yeah, I understand that one a little better now. Yeah.
Okay, so that's the concept there. Let's now try. Do you still need this?
No, it's fine.
Okay, you'll see it on the video later if you need to see it again. Let me flip my page. Let me not flip my page. We have right here. Look at this problem on top. I need to get the least common denominator of x minus 3, x plus 5, and look at this mess. Oh my goodness. I've got to factor this in order to even do the least common denominator. So, are you good at factoring these?
Yeah.
Okay, good.
Yeah.
Then I'll just write it out. X plus 5, x minus 3. And like I said earlier, the book cheats. Look at this. The x minus 3 is the same as that. The x plus 5 is the same as that. So remember the kids example earlier. What does each kid have that the other one doesn't? This kid has everything that these two kids have. It already has an x plus 5 like that and an x minus 3 like that. This one needs an x plus 5. This one needs an x minus 3. It looks like our least common denominator is x plus 5, x minus 3. I'm going to put that for each term. I'm distributing already. X plus 5, x minus 3, x plus 5, x minus 3. Now, before I go any farther, do you understand what I just did?
Why didn't you put the x plus 5 for the denominator for like the second one to the right? Yeah.
Why did I put this here? Or why didn't I put it down here?
No, the x plus 5. Why didn't you put that down there?
Why didn't I put it down here?
Because you say you're trying to share, right?
Yeah. So there's two ways to do these. I can make all the denominators look the same, but it's much easier to find, like kind of on the side, what denominator will make everything cancel out. You see that I use the same thing on all four sides, right?
Yep.
And if you look at each term, the bottom of the fraction cancels out every time. That's our goal. Our goal is to come up with something that will cancel out every single fraction within the fraction. And it's the same process as the sharing, like you said. I know earlier we said, oh, x plus 5 over x plus 5. This is similar, but not exactly the same. We could do it that way as well, but it's more difficult. Let's finish this and see what happens, and we'll come back to questions. Right here, we have only a 6. Right here, we only have 1 times x plus 5, but there's a minus sign. Down here, I have 1 times x minus 3. And over here, I have to FOIL this. And I already know the answer because they gave it to us. X squared, whoa. Plus, there's a plus here. X squared plus 2x minus 15. Simplify the top. Negative x plus 1. Simplify the bottom. X squared plus 3x, and then minus 18. Does the bottom factor? It does. It's going to be x plus 6, x minus 3, but those don't reduce with that, so I'm going to leave it alone. I don't have an x plus 6 or x minus 3 up top. Okay, Sharif, go ahead and tell me again. Do you have any questions on this one? What else do you want me to verify here?
No, I think it looks pretty good.
Okay,
I
even
think
though
I'm
it
fine with
doesn't,
this one.
yeah, even though it doesn't match what we did before, this is definitely a process and it works. So if you do this process for each of these complex fractions, it'll work and you'll get the right answer. Let's go down to number 76. And I have something plus fraction over something. This is my only denominator. Let's multiply everywhere by radical 5 minus x squared. And I have two terms here that I have to distribute it to. So be sure to write it for each one. I'm distributing already. You can see how I wrote it on each side. So it goes like this. Okay?
No, I can't see the bottom part.
How about there?
Yeah.
Okay. So I wrote the radical 5 minus x squared for each one of these. Let's start up here. And that gives me 5 minus x squared. Let's cancel these fractions, and that goes plus x squared, because that's all that's left here. On the bottom, I don't know if it's going to do much. 5 minus x squared, and then minus x squared.
Can you go just a little bit more?
Like that.
Yes, thank you.
Minus x squared. Okay, so I didn't do anything on the bottom, but on top you can see I multiplied the two radicals that are identical, getting rid of the radical. And over here we have x squared. Hey, look at this. Negative x squared, they cancel out. I'm left with 5 over 5 radical 5 minus x squared minus x squared radical 5 minus x squared. Okay. I don't think I'm going to go to the next step on this one. I'm not sure they're expecting you to do that, but we can rationalize the denominator too. We can multiply by the conjugate and get rid of our radicals on the bottom. But that seems very tedious and very long. So this is the whole idea, to get rid of the complex fractions. We'll stop it there for that one. And if we need to, we'll do more about it tomorrow. I'll do a little research and see what answers they're looking for. Okay. We have one more problem to do on the back. Okay, can I flip the page?
Oh, yeah.
Okay. So let's do one, let's call it a weird problem. I have an exponent here, and I have exponents here that are negative. We should simplify what's inside before we do this negative second power. So x to the negative first is 1 over x. X plus 1 to the negative first is 1 over x plus 1. And we still have that negative 2 out there. Now we're going to do like we did earlier. What does one have that the other one doesn't? And this one needs an x plus 1. This one needs an x. Now I can combine my fractions on the inside. I'm going to ignore that negative 2 for a while. 1 times x plus 1 is x plus 1. I've got a negative 1x. And underneath, I've got x plus 1. My x and my negative x cancel out. That's pretty cool. So I've got 1 over x times x plus 1, negative second power. Do you know what this negative sign does? It does the reciprocal. You flip it. Still have a 2, but now we got rid of the negative sign. And I know that something over 1 is just itself. And now I can square each item inside. I have a parentheses and an x. Final answer, x squared, x plus 1 squared. Okay, that's kind of an advanced problem, just to see, so you can see rational expressions in action in an even deeper sense than we had earlier. Any questions or anything else you want me to go over before we stop the recording? I can go over anything you want because it'll be beneficial to anyone else in the other periods as well. So do you have any questions from anything?
Can you do number 6 on the homework?
Is number 6 on the homework from the least exponent thing? The worksheet?
Yeah. We do all of them, right?
Yes, from the worksheet.
Yeah, I don't get number 6.
Okay. Can you go ahead and read it to me?
All right. It's parentheses x squared plus 4 parentheses to power of 3 over 2. And then plus parentheses x squared plus 4. And then to power of 7 over 2.
Okay. Just so you know, we read parentheses as the quantity of. So the
Okay.
quantity of x squared plus 4 to the 3 halves and so forth. My lowest power is 3 halves, so that's what I'm going to pull out. I'm going to factor that out. And what I've been telling you is on the inside, on the bottom, we put what we factored out. And on top, you put the problem. So on top here, we got x squared plus 4 to the 7 halves. And here we've got x squared plus 4 to the 3 halves. One of them is going to cancel out every time, and I can see it's this one. Because they're the same. They're 3 halves. When you subtract the exponents, you get 0, which is something to the 0 is 1. Over here, 7 halves take away 3 halves. Gives us 4 halves. That means we're going to have x squared plus 4 squared. Notice that the x squared plus 4 doesn't cancel out, but when you have a common base, you subtract the exponents. I still have this outside as well. I factored it out earlier. That's why the inside changed. Okay, this can be expanded. X to the 4th plus 8x squared plus 16. And we add 1 to it. That gives me x to the 4th plus 8x squared plus 17. All of this times x squared plus 4 to the 3 halves power. I'm done. If this were a negative exponent, we would put it on the bottom of the fraction. Emily, what do you think?
Okay, that makes sense. Thank you.
Okay. Is there another problem from anywhere that you guys would like me to do?
Did you do 12?
From the same worksheet?
Yeah.
Okay, I have not done it.
Okay.
Let's see here. Are you ready to read it to me?
Yeah. So you said the parentheses is the quantity of, right?
Right.
All right. So it's quantity of x plus 5. And then to power of negative 1/2. And then quantity of x plus 5 again.
Is it multiplied or divided?
It's multiplied.
Okay, x plus 5 again.
And then negative 1/2.
So it's the same quantity both times?
Yes.
Okay.
And then minus x plus 5, 1/2 to power 1/2. and then x minus 5 to the power of negative 3 over 2.
So this is the only one that's negative, right?
Yes.
Okay. So, it's interesting that they have two of the same thing with the negative 1/2 here.
Oh,
I'm
wait.
just gonna go ahead,
Sorry,
tell me.
the first one is negative. The first x plus 5 is negative.
Okay, so this is negative.
Yeah.
Now it makes sense. Okay, so first let's look at our x minus 5s, and my lowest power is negative 3/2. So I'm going to write x minus 5 to the negative 3/2. Then I look at the x plus 5s, and my lowest power is negative 1/2. So x plus 5, negative 1/2. So far, so good? I will assume so. So we want to write this on the bottom of each side. X minus 5, negative 3/2. X plus 5, negative 1/2. X minus 5, negative 3/2. X plus 5, negative 1/2. A little bit messy. Now we rewrite the problem on top. X minus 5, negative 1/2. X plus 5, negative 1/2. X plus 5, 1/2. X minus 5, negative 3/2. Let's start dividing. These cancel, and these cancel. So what's left here? I'm going to subtract negative 1/2 minus 3/2. That gives me 1. Over here, I've got 1/2, take away negative 1/2. That's going to give me 1. When I simplify this, I have x minus 5 minus x minus 5, giving me negative 10. Now I have to bring these down, and these are going to be in the denominators because they have negatives. I'm going to get x minus 5 to the 3/2 and x plus 5 to the 1/2. Done. What do you think? Thumbs up, thumbs down, thumbs sideways?
So it's it's x minus 5 to the power of negative 3 over 2, and then x plus 5 to the power of 1/2. Is that 1/2? I can't read that.
Negative 3/2, positive 1/2.
Okay.
Because you look at each factor and you take out the lowest power. So the lowest power of the x minus 5s is negative 3/2 over here. The lowest power of the x plus 5 is negative 1/2.
Oh, okay.
And that's what goes on the bottom. The original problem goes on top. Then you do your dividing.
Okay, thank you.
You're welcome. Adam, do you have any problems? Any questions?
No, I got it. Thanks.
Good. Sharif, any questions?
No, I think I'm good on this one.
Okay. Marcus, any other questions?
Just real quickly, back to number 6.
Okay. Let me find it. Here it is. Okay.
So you can only divide by one side of the equation, right? So you chose the quantity of x squared plus 4 to the power of 3 over 2, right?
Yeah, because it's a smaller exponent than 7/2.
And you're dividing that on both sides.
Yeah, I want you to think of this. Here's how to think of it. I'm really multiplying by 1.
Okay.
All of this here is one fraction, and I have it on the bottom and on top. So I'm multiplying the numerator and the denominator by the same thing.
Okay.
So it stays the same value.
Okay.
If it were an equation, we'd multiply each side of the equal sign. If it's a fraction, I have to multiply the top and bottom by the same thing. What else? Any other question? Are you sure, Marcus, you understand this? You want a simple example so you can see this in action?
I think I understand it. And then, so once whichever side you divided by, you still have to drag that down in the original equation when it's done, right?
Like this, you mean? Right here?
So you took out the quantity of x squared plus 4, power of 3 over 2. When you have your answer, that still needs to be on the outside, right?
Yeah.
Okay.
Yes.
Okay.
Okay. Really simply, I'm going to do it anyways, even though you didn't want me to. If I'm going to factor out of here, the number that comes out is 2, and I have to divide each of these by 2. So I know this 2 is going to come down because I factored it out, and I divide. So I have x plus 4. So this is the same process with much more complicated looking stuff, but it's exactly the same as this.
Yeah, I think that's where I got confused.
Okay. Any other
Sorry.
questions?
Yeah, I have one more question. I'm confused. We're able to do 14 to 16 on the homework. Like,
On the same worksheet?
yeah, on the same one.
Okay. Does it say something special on there, or is it just harder, or what is it?
No, it just says using factoring of least powers in algebra to make the left side of the equation equal to the right side.
Okay. Let me click on it so I can actually see the worksheet. And you said numbers 14 to 16?
Yes.
Okay. So basically, you're going to do what we've been doing, and they gave you the answer. That's all. So look at number 15, for example, right? You see how it has x squared plus 5 on the bottom without an exponent, with an exponent of 1? But on the next side, it says 3 halves. Here's what that tells me. That tells me somehow I'm going to factor out an x squared plus 5 to the negative 1/2 out here, and it's going to come downstairs with this. Let me do 15. You guys want to do 15 together? Let's do it. Then you guys get an advantage. You get to see the... Oh, look, I even turned the paper sideways. This is a real one. 15. 4 x squared plus 5 to the 1/2 x plus 3 cubed minus x plus 3 to the 4th x squared plus 5 to the negative 1/2. And I'm only going to write one side. I'm not going to write the other side. I'm going to work on this side until it reaches the other side. So I'm looking up here. Are you able to see what I'm writing? Everything's good?
Yeah.
Okay, so the x squared plus 5, here's my lower exponent. My x plus 3, here's my lower exponent. So that's what I'm going to factor out. I'm going to factor out x plus 3 cubed, x squared plus 5, negative 1/2. And I'm only working with the top right now. And I'm going to just, it's a process to write all of this out. I'm going to do the division right now. I'm going to skip a couple steps. When I divide these out of this term here, I'm left with 4. I'm left with x squared plus 5 to the first, because when I divide this out of there, I get 1/2 minus negative 1/2. And the 3 and the 3 cancel out. X plus 3 cubed cancels with that. Over here, I'm going to get x. 4x plus 3 cancels with this, leaving me with one of them. And this cancel out. So that's what's there over x squared plus 5. Okay? You see this right here? That already comes downstairs and becomes x plus 5 to the 1/2. Okay? And since I have the same base, this becomes x squared plus 5 to the 3/2, because I add the 1 and the 1/2. Now you see how it looks like the problem on the right-hand side of number 15. Let me continue to fix this up. I have x plus 3 cubed. I'm working on the numerator right now. And I've got 4x squared plus 20, and I've got minus x squared minus 3x. Okay. My 4x squared and my x squared, they cancel. So I've got 4x squared minus x squared. I don't like the way this looks, by the way. Just saying it. 3x squared minus 3x plus 20. And I've got x plus 3 cubed. On the bottom, I already look the same as what I'm supposed to look like. Okay. Now let me look at what the problem says. Oh, I'm done. It looks exactly the same. There it is. Check mark, happy face emoji. That's an M22 emoji. I didn't even know I'd be done right there, but it just turned out that's it. So I tried to make the denominators look the same, and then it turns out that the numerators look the same too after I did that. I think you're going to want to go back and rewatch that one.
All right, thank you.
You're welcome. The other two are the same way as that. Try to make the denominator look the same, and the numerator probably will pop out and look the same at the end. Another question? Okay. It's been about 40 minutes. I actually want to stop you now because I don't want you to have math burnout. I want everyone to take a break from their math before you start doing your homework and watching more videos. I'm going to turn off the recording now. So give me a moment.